Hi, in this video, I just want to quickly demonstrate the project I worked on. It was a collaborative project for a client, and I was mostly responsible for the server-side aspect, which is a Node.js-based server. But also part of my responsibilities were to integrate the server side to the client side, like of the game itself. So I'm going to show a quick playthrough of what it does. And actually, right now it's going to demo how it runs live, but I'm going to show a local host version of it too. All right, there's not much really to it when you first start. But essentially it's a hero collection game. You beat the bosses, you explore, and after attacking, you get more gold, you get a ton of different types of currencies. You get scrolls. If you're a Diablo fan, essentially you have a plethora of types of currencies at your disposal. Lots of things are missing a description, pardon me. The game is obviously still a little bit in development. So right now I just have the one hero. You get to see a little bit of his stats. Some images still missing. Let's ignore that. And the X button is not equipped or does not function. So that's something critical. Anyway, just ignore that for now. So yeah, I'm gonna redirect the server calls to look it up on my local host. I can actually just do. Pretty sure I can just do localhost here. This top one here is to fetch the JSON data that's fed into the game. That is a service, essentially something that converts on the server side the Google spreadsheet into a JSON format readable for the game. So it allows us to have like different types of versions of it. Like if we need a development spreadsheet, a test spreadsheet, and finally like the production spreadsheet. So far we've only like relied on the development spreadsheet, and we can version control it, or we were like up to version 8 so far, so we can take snapshots of it and then indicate in the game this is the one we're going to rely on, or if not, it's going to fetch like the live version of it, like sfdev. Development, test, production. Yeah, so as far as like the server-side API goes, to make the request for user authentication, I'm going to redirect this to my local copy. And now, let's see. It's not running, so it should complain. All right, sure enough, it does. Cannot connect to destination host, so let's get it up and running. Go quick npm start. Takes a bit of time to warm up the first time around. So you'll see a bunch of little things getting initialized. So I've set up in place like a request limiter. So like you can't exaggerate with a bunch of server-side requests if somebody was, for example, cheating to get a bunch of gold all at once. And then like there's certain capping, if it goes beyond 40 requests, then how much does it like threshold or like actually cap so that it kind of simmers back down, So if they do actually 80 requests, then it's not going to take 40, false requests to dip down over time. It's just going to gradually fall back down from 41 down to 40, and then it's good to go again. Mongo setup. So it uses a MongoDB database, gets initialized, uses Socket.io, not so much for the Unity side of things, but there's a web console that this provides as well. So you can actually go in and send out webmail, and then it gets pushed out to the game. Users gets notified, and they get a little whatchamacallit, a flag on their mailbox actually that goes up. No mailer to send out emails, which we don't do at this time, but it would be in a scenario where they're doing password recovery. GitHub, just to keep track of the commit hash, so that way we can rely on or like point out in the logs like we're correctly interfacing with the most up-to-date version. So it compares a commit git hash, and if it's not matching, there's a little warning that says, hey, you may be using a deprecated API. What else here? The web dashboard, that's the webmail essentially. Express routes, can't live without express routes really. This is for like creating the REST API. So there's a bunch of different routes for down to like user authentication, which funnels down to all the different types of web requests they could be doing. Fetching all their heroes, which items are equipped to each heroes, their inventory, the currencies, the loot crates, I guess whatever's all here, explorations, research slots, the shop, and all the logic side of like how a user would go to like buy an item in the shop. It's all processed on the server, so it eliminates chances of like cheat. I'm not saying it rules it out completely, but it drastically takes away some possible cheats they could do on the client side. Yeah, so that's how it prepares the server side. Now let's actually connect to it. So port 9090, yes. All right, it's connecting, and I've probably had to restart the server or the MongoDB database. So let's see if I create a new account. Maybe I just logged out last time. I guess that was the case. All right, so I guess last time I played I had 2 heroes. Let's go check out if I can go explore. Oh, that's the summoning portal. Exploring, there we go. Act 0. Just going to keep it on normal difficulty. And then this one. Let's go explore this one. And let's assign these 3. So you don't have to actually fill up the entire 5 slots. You can just use 1, 2, 3, up to 5. Let's do that. So there's a bit of a... There's a timer involved, and you could let it run. Or you could actually go in and attack. Just to show you, like this is maintained by the server. I'm gonna actually close the game, rerun it. Hopefully this auto logs me in. Looks that way. Sweet. All right, and now let's go back to Explore screen. And yeah, that looks about right. How much time was left from last time? So let's go in and help the explorers to help the heroes, rather, to beat the boss. Scale is a bit off on some characters, but it's part of game development. You run into some bugs. So again, beat the crap out of this dude. All right, so he's done. The tutorial screen, that was something Tyler, the other developer, worked on. Lots of changes since last time I played around with this game. What should we do? Inspect the tree? Sure. Explore it. I just want to get out of this screen. All right, another boss apparently. All right, just wasn't at the boss yet. Okay, so this is the boss fight. What you've seen was just like a exploration battle or tap battle. Since it's a mobile game, it's just like something fun for just constantly tapping on the screen. This is a bit more strategic though. You have to like use your skills to I guess more efficiently to beat the bosses. But since this is the first act, like a training act, I will probably have no difficulty to beat these guys. And eventually, boom, boss is dead. All right, so now, yeah, some labels are a little bit clipped off, but got a new treasure chest. Let's ignore that. So everything you're seeing from like finishing the exploration and whatnot, that's all being tracked on the server. Um, oh, you can actually see like some interactivity of what's going on. So incorrect username and password. That was like that first attempt when I first played it. And equipping items to hero 1. One items to 1. Equipping items 1 to 3. That may have been like an auto fix that gets applied when the game first launched. Or at least after a while from the last time it's been launched. So it does, on the server side, these auto corrections to make sure like items are properly connected to heroes and whatnot. So, and does it all on like the MongoDB database as well. Yeah. So in terms of like the C# implementation of this, let's just look for it. Game Manager, Game API Manager. I'm just loading it up on Notepad++ for now, just so I can like quickly show. So this is the hashtag or the commit hash on GitHub I was talking about. So the Node.js project, anytime it gets committed and pushed, this has to match that commit hash. Otherwise, we'd get a little warning in the console output. Just kind of a friendly way to say, hey, just to make sure the API integration is up to speed with the current version, update this. And it's kind of a ritual, I guess, or like a habit we get into whenever an API method gets added or like a new route. So for each section of the API, I make like a dedicated child API of that. So like the shop API, if we go down, so extends from child API, which is essentially kind of it's a generic, and then you can tell it like what type of MongoDB data class it would primarily make use of to represent its data. In this case, it didn't have one, so we just bind it to the interface of Mongo data. A better example would have been, let's see, I think messages. Nope. Heroes, probably. That's gotta have something. There we go. So a hero is basically just an instance of a hero, I guess. Like it's your own ownership of that hero. It's not like the definition of a certain hero, if that makes sense. So like the game has maybe 10 types of heroes. This is not to represent one of those types. This is to represent one instance of those types that belongs to the user, if that makes sense. It's basically an ownership object that can be tracked via a MongoDB ID. So yeah, here basically the hero API has an add method, so you can add the hero that belongs to this user whenever they summon a new one. You can add multiple ones at once, so it basically piggybacks on, well, the singular version piggybacks on the add many version. Basically populates a JSON object and then transfer that over the API. And it does an API.send while logged in. And if we dig deeper, what that actually means, which is probably Node.js Manager. So while I was building this API on the client side, I tried to keep in mind, well, maybe this could be useful for other projects. So why not make like the Node API Manager a bit more self-contained or standalone, and just extend from it with a more game-specific context. So Game API Manager is the game-specific context one, the subclass, and the Node API Manager, or Node.js Manager rather, is like the top level class. Well, it extends Manager singleton, but you can ignore that. That's just kind of a helper class to have a bunch of getters, setters available. But Node.js Manager is what has what's it called? Send while logged in. So anytime we need to make to send data over the wire to pass information pertaining to the user, it has to be done like send while logged in. If it's just sent, doesn't really matter whether the user is logged in or not. Like if we're sending the logged in credentials, it would be done through the send API, through like a part of the service side that allows anyone to contact it. The user doesn't have to be logged in. Otherwise, no one could be logged in, if that makes sense. And then you have like all kinds of controls on, okay, does it expect JSON as a result? The request to be sent as JSON, the request to have an authorization portion. And the reason like why this one does, even though it's kind of the public API, is like I kept in mind that, okay, if we have an app tailored for one specific game, we probably don't want like anyone just to like randomly send a request without like knowing what the context of this API is for. So there's an authorization string that has like a prefix, and that prefix is kind of unique to the game, kind of a secret key, but not really, not that secret. And then that authorization string, after they get logged in, we append the information about the user, like their OAuth key, if you will, or like a token. And essentially when anything goes across the wire, we send it via a this goes deeper here. It goes through a bunch of pending requests, like that gets added to the list, and the pending request list just plows through all the requests on a frame by frame basis. Like whenever it's not busy, it just requests the next one. I just made it this way so we're not like spitting out a bunch of HTTP requests all at once, especially if we can only handle 4. This addresses a bit more like problems with the race conditions if you don't know the exact order of the results, it could, cause cause problems in the game. So yeah, that's like the coroutine that handles that pipeline or the array of requests. And lots of verification. If there's errors, it bubbles it up through C# promises. So this neat library I found, actually, Newton JSON. Excuse me. Real Serious Games, RSG, provides this library to define promises. So I made a lot of use of this. After I've learned promises on the Node.js side of things, I was really glad I could find an implementation of it on C#. And what it looks like, essentially, like a actual usage of it. So you can send a request, and then your promise, you put your then clause, and then the result, or response rather, shows up here. You can access it like an array. And then if there's any errors, you can catch it and then trace the error or debug, log it, however you do it in Unity normally, and format it however you like. Yeah, so these two classes are essentially what I worked on to get like the server side integrated. If there's anything else you'd like to know, I'm gonna put an end to this video for now, but let me know via email if you know my address. And yeah, hope this kind of showed a bit my responsibility on this game. And I'll talk to you later. See ya. Bye.